So we'll take the gist of is again the Toy-Sellian experiment. A beaker containing mercury was taken in which inverted tube filled with mercury was poured, and then we saw that only 76 centimeter of mercury was held by, either you can call it Toy-Sellian vacuum, or it was held by the atmospheric pressure which was applicable on the other parts of fluid which was open, right? So according to that we just derived the value of atmospheric pressure as to be 1.013 into 10 raised to power 5 pascals, right? And considering this value of atmospheric pressure, we can also find the height of atmosphere, see, or height of vertical gases above us till the till what height these gases are extended up to. So using this theorem or theory, if I use P is equal to H rho g, I already know the value of atmospheric pressure, which is 1.013 into 10 raised to power 5 pascals, whereas height of air column above us, I don't know the value. Density rho, air is supposed to be of density 1, to be approximate it's 1.3 into densities 9.8. Putting all these values, I'll get height to be about 7951 meters, or it's approximately equal to 8 kilometers, right? 8000 meters or 8 kilometers. So that means atmospheric gases extend from this height till 8 kilometers, which is not true. We know that, right? So where is the flaw coming? Flaw is not in the formula. Actually, the air density of air or gases above us from the Earth's surface decreases variably. For example, the density of air is half at the height of 8 kilometers and is 1/20th at the height of about 20 kilometers. So density varies very drastically, and that is why we do not take this height to be density. In fact, atmosphere we take the, in practical situations we take atmospheric height to be of around 400 kilometers. Just remember one fact, that above 50 kilometers only 1% of the gases remain. Above 50 kilometers only 1% of the gases remains, rest all is ions and everything. So this was Toy-Sellian experiment. So now since we have done atmospheric pressure, let's go through some important SI units which we use to study atmospheric pressure. First of all, we measure pressure in pascals, right? We have already studied that. Then atmospheric pressure is measured in either centimeter or millimeter of mercury column. Now torr is also used to explain or to quote values like this. So torr is 1 millimeter of mercury. Now for meteorological purposes, there is another very bigger unit of pressure which is called bar. 1 bar is actually 10 raised to power 5 pascals, and there is 1 millibar which is 10 raised to power minus 3 bar, or 10 raised to power minus 3 into 10 raised to power 5, which makes 10 raised to power 2, that is 100 pascals. So these are most common units which are used to derive or to represent the value of atmospheric pressure.